Hello, everyone. I'm CDO of ValueCommerce. My name is Matsumoto. It's kind of abrupt, but let me ask you a question. When you develop and operate your services and products, you may have experienced system overloads due to periodic campaigns or sudden traffic spikes, and you had to quickly scale up servers and had difficulties maintaining those servers. At ValueCommerce, in services named Stores R8 for merchants on Yahoo Shopping, every time there is a regular campaign, the system would stop due to increased requests and delay because of increased data. In this session, I will talk about examples of stabilizing the system and reducing the cost of maintenance, operation, infrastructure by rethinking the system architecture to solve the sudden increase of requests and data and subsequent system overload. So this is the agenda of my presentation today. I would like to start with the service, Stores R8. Majority of you may not know, so let me give you the overview of the company, of the service. Stores R8 is offered to stores on the Yahoo Shopping. It covers needs from wanting to acquire new customers to guiding existing customers to loyal customers. Generally, it is referred to as CRM, Customer Relationships Management. Let me just briefly explain what they can do. Stores can see the details of their customers. For instance, what is the purchasing amount of a Yahoo Premium member, or how many have made the purchase, at what frequency, what are the signals of customers who have not made purchases for some time. Based on the analysis result, they can introduce most cost-effective campaigns, like issuing coupons for new customers or designing campaigns personalized for their customers. So for each customer, you can design various marketing measures. Thus, on top of Stores R8, stores can set up their targeting, segmentation, and coupon information. When a customer comes to the site and views product detail pages or cart pages, an inquiry is made by the Yahoo Shopping server to the ValueCommerce API server, and if it matches the set targeting condition, the coupon will be given to the customer. Conventionally, a request from Yahoo Shopping to ValueCommerce API can cause a load of about 1,000 requests per second, or RPS. Yahoo Shopping launches a regular discount campaigns every Sunday or on days ending 5 every month. Requests increase from approximately 5 times the normal amount during a regular campaign up to nearly 10 times during large campaigns, such as the annual Super PayPay Festival. Let me now explain the system's configuration of Stores R8. It's a very simple configuration. The request from Yahoo Shopping was received by Java Servlet, the segment and coupon information set by the store, and the customer's information stored in the RDBMS will be compared. The architecture returns a coupon that matches the conditions.
In order for the stores to conduct the analysis of the customers, there will be a huge amount of data, such as the purchase information and the access log. We needed to aggregate that. So data is stored in RDBMS, and aggregation was implemented using Apache Spark. For the infrastructure, AWS was used, and also RDBMS uses AWS RDS. Based on this system configuration with the normal load, the API from Yahoo Shopping can be returned within 500 millisec without any problems. And also the aggregation process usually took about 5 to 6 hours. But the other day, there was a campaign of the Yahoo Shopping, and when the request increased all of a sudden, the API became overloaded and the response worsened. And in the worst case scenario, the service was suspended, and updating the user data, that is to say that creating the segment of the users who looked at the specific product, and we want to tie the user to the data, this updating process was delayed. And also the aggregation process of the data for analysis took more than double the time. This happened many times. So when there is an overload of the store's R8 API system, when the customer comes to the Yahoo Japan Shopping, from the server, there's no response to the request. So for example, even if the customer should have received a limited coupon, the customer will not see the display of the coupon and cannot use that coupon. Especially in the case of major campaign, for the stores, this is a major opportunity to increase the number of customers as well as conversion. So if you cannot see the coupon that you're supposed to see is a major problem. And as the volume of data increases, the aggregation for analysis takes more time. And also it becomes impossible to validate the effect of the measures analyzing the purchase information and others. So in order to deal with those issues, first of all, we improved the part which requires heavy processing as an application, and also we did the scale up and scale out of the AP server before the campaign and tuning of the number of the processes so that we can deal with the increase of the load. But despite those, as the request and data increases, the back-end data acquisition part has become the bottleneck. The user attributes and the behavior data and the segment and the coupon information set by the stores are managed in RDBMS. And in addition to the request from the distribution, there was a batch processing at the background happening in non-real time. So when there is an overlap of the update batch process and the distribution request, in some cases we needed to restart the process. So during the campaign, it was necessary for us to monitor this all the time. Also, scaling up and scaling out of the RDBMS as a countermeasure for the high load, user data can be sharded with a user ID, and before the campaign, it requires a certain cost to do the pre-resharding. And also, if you do the scale out all the time, that would increase the infrastructure cost. So we decided to improve the system configuration fundamentally and change the system architecture that is resistant to load. Now, in order to do that, we first need to identify the current issues of the architecture. So we looked at the 3 points: deliver server, user data, and aggregate process to improve the architecture. Now let me talk about each point. Starting with the deliver server, which receives the direct requests. So if I go through the flow of the deliver server, the customer on the Yahoo Shopping accesses a particular product. So from whom and which product of which store, in order to identify the access, when there is a request, the user identifier and product code are added. And at the deliver server, based on this identifier of the user, the server would obtain the attribute information of the user and the past action. So based on the product code, the store on the stores R8 will obtain the campaign and coupon data. And in this coupon data, there is a targeting and segmenting information specifying a particular user. So looking at each data and finding the product that matches the user, and a response of matched data will be returned. Concerning the user data, it's tens of millions of records. As for the coupon data, it's the number of the real-time active data, so it's thousands of data. So all of those data came from RDBMS. If that is the case, at the time of the overload, this becomes the bottleneck. So stopping the connection to RDBMS, instead, user data is stored in the key value store or KVS, and coupon data is stored on the local memory. That's what we thought about. And API itself, we have decided to use the Apache module so that we can directly embed the module to Apache, and we already use that for the affiliate system. As for the coupon data, open source MDBM was used, provided by Yahoo. And in the case of coupon data, one store has multiple coupon data, and each coupon data has the targeting, segment condition, and other structured information. So we were thinking of keeping it in using JSON, but at the deliver server, it is not necessary to update the coupon data, so it was read-only. So we were concerned about the parsing process and others. So we implemented the value in direct C language structure.
By storing a coupon data in MDBM directly in the C language structure, value is obtained by using the store ID as the key. There's no need to do the parsing on the deliver server. Fast processing is now possible. Here is the overall structure around the deliver server or distribution server. Coupon data set by the store can be searched. Data from the RDBMs can be obtained in advance through periodic batch processing. And by creating the MDBM that I mentioned earlier and distributing it to each distribution server, coupon data can be found without costly communication with external servers. Now let me move on to the second systems improvement. This is the user data retention. In stores R8, in addition to the user's attribute information, the store needs to keep all the behavioral data as targeting data, such as when each user accessed the product information and which product they purchased. These data are kept in each table of the RDBMS. When there is a request, data relevant to that specific user will be all extracted for a decision to be made. Here again, the more the user's behavioral data, the more data volume, and the higher the search cost. So we decided to keep the data in a key value store with the user ID as the key and the related data as the value. By employing KVS as a data store, search cost of a specific user will be lower. Simplify the key value format when there is a various data in the value. Data size per record will be so large, it makes it necessary to extract all the information about the specific user every time. This is not very efficient because it only refers to the needed information. So that's why we now have the categories like attribute, access, and purchase. The category information is kept as a value. So that's the key value structure. We actually use reddish hash in the JSON format, we keep user ID in the key and keep the field in the subkey. So more granular information in the value can be kept. We were planning to do sharding with user ID, but considering user-related data growing in size, we decided to compress the value. As our data store was switched to KVS, we now have the advantage of pulling all the relevant data in each category based on the user ID. On the other hand, caution is needed for data updates. To update respective elements in JSON in the value, client needs to bring the data with get and modify it, and then update it with set. When multiple processes run parallelly, there is a possibility that data loses consistency, so the atomic updating is necessary. Redis has a transaction function that can process data atomically by sandwiching the commands with multi-exec. That said, processing like rollback or error handling are rather complicated on the client side. So we decided to execute the Redis module to process in one go on the KVS side. The concept of Redis module is similar to that of a patch module. By extending the Redis functions, it is possible for users to freely combine commands and data structures. Similar structure is found in Lua scripting, the Lua language that enabled the processing to be embedded on the server side. Its usability has improved. And by implementing it the way the low-level API of Redis is directly called, it can process much faster than the Lua scripting. Here is the implementation with Rio stores R8. Each unique command decompresses data as pre-processing for the reference system, and compresses data as a post-processing step for update systems. For the update system, by implementing commands to update only specific elements of a specific field, the client does not have to worry about the compression process or atomicity. On the right-hand side, you will see the proprietary hget command as an example. The interface is similar to the standard hget command. So when you study data without worrying about the compression, you can pay attention to operational ability. Lastly, I want to talk about the third point of aggregation process. Stores R8 needs to aggregate stores customer data, purchase data, and access logs from different perspectives. Especially, processing is quite heavy in RFM, recency, and frequency, as well as monetary, the purchasing value. For each, there is a function to enable ranking based on up to the past 2 years' data. Ideally, since each customer is ranked by the previous day, based on the purchase information of the first day and that of the previous day, the recency, frequency, and monetary value are calculated. If the difference exceeds the set threshold, the ranking should be renewed. When the store changes the threshold, re-ranking becomes necessary even for the customers that are already ranked. So every day, each store needs to aggregate the past 2 years' purchase data and enormous amount of all user data.
Aggregation process itself can be handled in a distributed manner at Apache Spark. data acquisition, and the write of the aggregation result was to RDBMS. So the intermediate data was written to RDBMS and the repeatedly read. While the campaign is going on, the number of the requests increases, and the data volume also increases. So in order to not to be late, we want to increase the number of the Spark nodes. But if you have a higher number of the nodes, the read and write load to the RDBMS will double or increase further. When RDBMS becomes overloaded, in the worst case scenario, there is an aggregation error. So depending on the volume increase of the data, it will not be possible to increase the number of the nodes. So we could not fully utilize the distributed process function of Apache Spark. So during the campaign, in order not to be late in the aggregation, we managed to scale out the RDBMS according to the number of the nodes at the Spark. But there was an infrastructure cost issue. This is something that is overlooked from time to time, but our AWS RDS is built based on not only the data volume and cluster instances, but also on the number of I/O requests. So at the stores are 8 aggregation processes. The configuration was such that we need to read and write detailed data in a huge volume. So the infrastructure cost used to be 5 to 6 million yen per month. In order to solve those issues, we considered this configuration or architecture. So first of all, read and write of the data is changed to AWS S3 from RDBMS. In the case of AWS S3, the billing is also based upon the number of the requests, but in comparison to RDS, it's cheaper, and the read and write can be done not for each record. All the necessary data can be read from S3, and the intermediate data can be held in Spark. So aggregation results can be written to S3 as a bulk. So aggregation result written to S3 is batch processed to RDBMS, and as a result, we can reduce the number of the I/O requests of S3 and also to the RDBMS. At the timing of the writing to RDBMS, the load increases, but the volume of the data of the write has decreased. And as we can control the timing, we can do this during the night. Now, with the AWS EMR, input goes to S3, and each node will read each file. So even if the data volume increases as we have more division of the file, we can scale this in a flexible manner. At the time of the aggregation, the behavior data and the purchase data, that is the transaction data, are read, and there will be reformed in the Apache custom log and output, and using the FluentD, it will be uploaded directly to S3. So we read the aggregation data from RDBMS, and this process of uploading to S3 will become unnecessary. So the threshold information of the ranking set by the store, and also other information set at the management screen, are stored in RDBMS. So before the starting of the aggregation process, the latest data can be read from RDBMS and uploaded to S3. So we don't have to have a connection from each node of the Apache Spark to RDBMS. By doing this, depending on the data volume, we can increase the number of the node of the Apache Spark. So we can fully utilize the distributed processing function. Now the cost is reduced for the RDBMS, so we can increase the number of the node of the Apache Spark and shorten the aggregation time. And as a result, the infrastructure cost was reduced to 1/5, to about 1 million yen per month. So briefly, I talked about the deliver data, user data, and aggregation process, and I talked about the improvements that we made. Actually, there are other changes of the logic and other minor processes. So this was a major modification. But compared to the before the modification, the number of the servers, the time required for aggregation and infrastructure were all reduced to about half. And also during the campaign of the Yahoo Shopping, we preparing for the scale out or scale up, or monitoring all the time during the campaign was no longer necessary. So we could drastically reduce the maintenance and operation costs. So far I talked about how we try to deal with the increasing request and reviewing the architecture and gave you the example of the ValueCommerce Store R8. So what I wanted to communicate to you is that as you develop and operate the services, of course, we have to consider the scalability to design the system and develop the system. But when the service grows very rapidly, the volume of the request and data increases, and unexpected places will have new bottlenecks due to the campaign. So with the simple scale out and scale up, you cannot handle this, and you need the provisional application modification. Of course, we have to solve the problem so that we can continue with the services, and we need to consider many things to deal with it. But if you repeat the provisional solutions, application quality could come down and the maintenance costs could increase. And without noticing, the infrastructure cost could increase. So when that happens, fundamentally changing the architecture, of course, this requires a lot of work, and it's a major investment, and probably you cannot spend so much for the countermeasure against the load. But in the medium to long term, to reconsider and revisit the system configuration at a certain timing will lead to the lower maintenance and operation cost and infrastructure cost. So when you are struggling with how to deal with the high load, I hope that you will consider fundamentally making improvements so that your architecture will be more resistant to loads. With that, I'd like to end my presentation. Thank you for your attention.
Thank you, Mr. Matsumoto. We're going to have a plus talk. There will be questions asked on the session. And you can also ask questions. We try to take your questions as much as possible. If you have a question, please use the question mark button on the lower right-hand side of the screen. Our interviewer is Mr. Toshiya Kato from LINE. Would you like to introduce yourself briefly? Thank you. Sticker shop. I usually engage in SRE of sticker shops. As we're dealing with overloading issue during the campaign, so it has been very interesting. Thank you very much. So, Mr. Kato, listening to this presentation, anything that you would like to ask? First of all, on page 14, or around there, you talked about 3 major improvements. So those 3 improvements are based on completely different perspectives. So in terms of organization, were you working on these all at the same time, or did you complete one, go to the next? At our company, ValueCommerce, we do not have a large development team. So when we're working on these, there is a team of engineers, 4 or 5, who are in charge of stores RA, including developers and those who are in charge of operation. And this operation required a lot of resources then. So having this team of 4 or 5, trying to improve the system as much as possible. And these 3 improvement points that I mentioned earlier, did we make this switch all at the same time? Or rather than doing so, we focused on delivery server. When this went well, we focused on user data and then aggregation. In this way, there will be always 2 or 3 engineers working on one issue, and the whole work around took about a year or so. So the system that is already in operation, you have regular loading, and as I mentioned earlier, you need to have engineers stand by for campaigns as well. It must have been very difficult to make sure there are always resources there. Did you try to reduce the operation load as well? Yes. As a matter of fact, every time we have a campaign, we all had to monitor it constantly and make sure that we have scaled out. So all the resources need to focus on that. So during off-campaign period, we are collecting information on some trouble, error. We try to improve them. So that's how we allocated our time.
Thank you very much for giving us a very much details. Talking about the modules, I would like to have a question. In Japan, probably in the world as well, the Redis module itself, I don't think there are a lot of precedents. Functionally, it's this 4 cores or Redis 7, so it's not new, but it's relatively new function that you showed us. So challenging this new function, internally, were there any different opinions? Well, actually, Redis module, using that in the production, I think that this was the first example, star R8. So Lua scripting, server-side processing was done, but actually in the affiliate system, Apache module and Redis module is very similar to the Apache module. So with Redis, using C language and the lower layer, embedding it in the module, when it became available, this was something that we were waiting for. And I did the research, and as I tried to use it, so before embedding it to the product, we needed to verify, and we could check that we would not have much problem. So we went ahead and used it. I see. So AWS, you operate with AWS. So in the case of AWS, there are mainly 3, EC2 and the self-management, Elastic Cache, and also the memory DB, those 3 options. So using module EC2 is used. Yes, that is the only demerit or disadvantages. The Redis redundancy structure or configuration is a benefit of the managed. So we want to use it, but Elastic Cache, Redis module cannot be enabled, so we are operating with EC2. We are getting the question, the Redis, the replication and the file persistence all are not synchronized. So when it is written, then it's possible that you will lose it. But in this example, were there anything that you did to prevent that? Of course, as soon as it goes down, yes, at least there will be some loss. That's a risk. But from the deliver server to the Redis module, we try to make it possible to update, and also the recovery on the deliver data server. We have a log, so when something happens, we made it possible to recover. So that was done on the maintenance side. So until now, or so far, it did not have that problem. It's stable. Yes, in some cases, the load increases. The hotkey data update, for example, it goes up. But in the operation, we managed to recover. We are managing with the recovery.
Now, in terms of operation improvement, utilizing human resources. You only had a team of 4 or 5. And then the team was able to fundamentally resolve the problem. So CTO, as a CTO, you're a part of the management. Has there been any challenge in the part of management? Yes, as a management team, the systems refactoring required a lot of resources, but it was a very difficult decision. On the other hand, for a week, for example, if we say that refactoring requires a whole 1 year, can we wait providing enhancement? That's a difficulty once again. So we need to find a balance. The resources to add enhancement. We have to make sure that we have all the resources, and perhaps 30 or 40% of the resources should be utilized for refactoring. And also another thing is that we have to have good communication, regular communication with the management team, so that the overall cost can be reduced. We have to have them understand the possibility of reducing cost as well. I see. In this specific case, Yahoo Shopping, that is B2B, there may have been requests made by Yahoo, and might have been difficult to control the campaign timings. So you need to have good communications with clients. Have you talked to clients often? To Yahoo? Yes. Yes. Of course, we are telling Yahoo the plans to add functions to stores array. With regard to systems loading, we were so close to a critical overloading. So if we are going to add a new program, of course we make an estimate beforehand. So at the estimate of application improvement as well as possible loading added. This has been a long-standing problem. So really wanted to fundamentally resolve this. So this overloading estimation, possible reduction of load, yes, we did communicate on that point well. Other than that, did you conduct the joint overloading test, the load test? In the back end of the source array, we made a complete switch about 2 years ago. Back then, we did not conduct close joint load tests with Yahoo, but more recently, there is a PayPay Festival. We have one toward the end of this month. So before a large campaign, we carry out load tests, including ValueCommerce side APIs. Yes, we do work jointly. So that's nice to be able to work jointly, to be able to discover new challenges, new problems.
So from now on, now you have a new architecture, but any further improvements that you want to make? Well, this time, including the resources, there are several things that we were thinking about beforehand. In our affiliate system, already we use the distribution server, the coupon data side, adding the conditions, and those conditions applying to the user. That part of the logic, you saw that at the RMD event, and whether it matches logically is implemented in the natural language. But what we use for the affiliate system is the Lua language being embedded. So the C language doesn't have to be implemented, so more flexibly the judgment can be done. So using the Lua script, and the Lua script is the only one which is kept. So from the C language, it only executes, and whether it matches or not matches was something that we wanted to do. But due to the resource issue, we could not do it. So we want to include that sometime in the future. So we want to make it more flexible so you can accommodate the different cases. That's something that I look forward to. Thank you very much.